Good day to all of you. Myself, Dr. Arvind Sharma, Associate Professor in Physics, Government Donga College, BIKANER. Today we are trying to understand about the hydrogen atom problem using Schrodinger equation. In last few lectures, we are trying to understand about spherically symmetric potential problems and rigid rotator. The solutions of these two problems are also used in hydrogen atom. Okay, now let us start. We know that hydrogen atom may be regarded as a system of two interacting point charges. Hydrogen atom can be treated as two point charges. That means there are two charges which are interacting, and such kind of system we are using in hydrogen atom. The positively charged nucleus consisting of a proton and a negatively charged electron revolving around the nucleus. Proton and electron. Okay, nucleus. There is not proton, there is nucleus consisting of a proton. That means one is nucleus, second one is electron. For a system of two or more particles, the equation of motion can be more conveniently written in the form h psi equal to E psi, where h is the Hamiltonian operator, psi is the eigenfunction, and E is the energy of the whole system. Okay, so h psi equal to E psi, common Schrodinger equation. If x1, y1, z1 and x2, y2, z2 are the Cartesian coordinates of the nucleus and the electron, and m1 and m2 their masses respectively. If x1, y1, z1, x2, y2, z2 are the Cartesian coordinates of the nucleus and the electron, and m1 and m2 their masses respectively, the Hamiltonian of the system is given by h equal to minus h bar square upon twice m1 del 2 upon del x1 square plus del 2 upon del y1 square plus del 2 upon del z1 square minus h bar square 2m2 del 2 upon del x2 square plus del 2 upon del y2 square plus del 2 upon del z2 square plus v, where V is the potential energy. Kinetic energy plus potential energy, and there are two terms for kinetic energy. Okay, one for nucleus, second one for electron. So the Schrodinger wave equation for the whole system is written as minus h bar square upon 2m1 del 2 upon del x1 square plus del 2 del y1 square plus del 2 del z1 square psi t minus h bar square upon 2m2 del 2 upon del x2 square plus del 2 upon del y2 square plus del 2 upon del z2 square psi t plus v equal to et psi t, where psi t and et are the total eigenfunction and the total energy respectively, where psi t and et are the total eigenfunction and the total energy respectively. Equation 3 may be written as 1 upon m1 del 2 psi t upon del x1 square plus del 2 psi t upon del y1 square plus del 2 psi t upon del z1 square plus 1 upon m2 del 2 psi t upon del x2 square plus del 2 psi t upon del y2 square plus del 2 psi t upon del z2 square plus 2 upon h bar square et minus v psi t बराबर 0. In general, the potential energy V of the system may be written as, what is potential energy? V equal to Ze minus C. Ze for nucleus and minus C for electron and magnitude of R. That means V becomes minus Ze square upon under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Now, according to this, equation 4 can be separated into two equations. This is equation 4. This equation can be separated into two equations. Equation 4 can be separated into two equations. Equations 4 can be separated into two equations. One of which represents translational motion. Two equations. One for translational motion of the whole system, that is the center of mass and the relative motion of the whole of the two particles. Okay. Second one is relative motion of the two particles. One is translational motion of the whole system, that is center of mass. Translational motion of the whole system, that is the center of mass. And the relative motion of the two particles. In order to separate the two equations, let us introduce new variables, x bar, y bar, z bar. The Cartesian coordinates of the center of mass of the system, and r theta phi the polar coordinates of the electron relative to the nucleus. Again, x bar, y bar, z bar. New variables, the Cartesian coordinates of the center of mass of the system, and r theta phi the polar coordinates of the electron relative to the nucleus. These new coordinates are related to the Cartesian coordinates. These two new coordinates are related to Cartesian coordinates and of the two particles by the equation x bar equal to m1 x1 plus m2 x2 upon m1 plus m2. This is for x bar. Y bar equal to m1 y1 plus m2 y2 upon m1 plus m2. Z bar equal to m1 z1 plus m2 z2 upon m1 plus m2. X bar, y bar and z bar. Similarly, x2 minus x1 equal to r sin theta cos phi, y2 minus y1 बराबर r sin theta sin phi, z2 minus z1 बराबर r cos theta. Introducing these two variables in equation 4, we get the equation 1 upon m1 plus m2 del 2 psi t upon del x bar square plus del 2 psi t upon del y bar square plus del 2 psi t upon del z bar square. This is first term. Second term plus 1 upon mu 1 upon r square 1 del upon del r square del psi t upon del r plus 1 upon r square sin theta del psi t upon del theta plus 1 upon r square sin square theta del 2 psi t upon del r. If we see this bracket term, this is for its spherical polar coordinate system del 2 function, del 2 psi t plus 2 upon h bar square et minus vr psi t बराबर 0. When psi equal to m1 m2 upon m1 plus m2 equal to reduced mass of the system. What is mu? Reduced mass of the system. Let us now apply the principle of separation of variables to separate the two equations. Now we want to separate the variables. Let us now apply the principle of separation of variables to separate the two equations. For the purpose, let us assume psi t equal to x bar, y bar, z bar, r theta phi. Psi t is function of x bar, y bar, z bar, r theta phi equal to f x y z psi r theta phi. Psi t equal to f psi. Substituting this value of psi t in equation 8 and dividing by f psi, we just substitute the value of psi t in equation 8 in this equation and dividing by f psi. That means we are trying to separate the variables. Now this equation becomes 1 upon f m1 plus m2 del 2f upon del x bar square plus del 2f upon del y square plus del 2f upon del z bar square plus 1 upon mu psi, and the same term del 2 psi plus 2 upon h bar square et minus v are barabar 0. Now just take the left hand term for f term function of f, that means f term is in left hand side and psi term on the right hand side, because psi is f psi. F is left hand side, psi is right hand side. So we separate the variable, and similar argument. Left is function of f, right is function of psi, but both are equal on in the special case when the result is equal to constant. In above equation, left hand side is function of x bar, y bar, z bar, because function f depends upon x bar, y bar, z bar, and right hand side is function of r theta phi, because f is function of x, y, z and psi is function of r theta phi and is independent of x bar, y bar, z bar. Therefore, if above equation is to be satisfied, both sides must be equal to constant 2e upon h bar square. 2e upon h bar square, 1 upon f m1 plus m2 del 2f upon del x bar square plus del 2f upon del y bar square plus del 2f upon del z bar square plus 2 upon h bar square et बराबर 2 upon h bar square a. This equation becomes del 2f upon del x bar square plus del 2f upon del y bar square plus del 2 upon del z bar square plus 2 upon h bar square m1 plus m2 et minus e f बराबर 0 and minus 1 upon mu psi 1 upon, this is bracket term is del 2 psi plus 2 upon h bar square vr बराबर 2 upon h bar square a. Now our r equation becomes 1 upon r square del upon del r square del psi upon r, same term. This is del 2 psi up to here in spherical polar coordinate system, and this is 2 mu upon h bar square e minus v bar psi equal to 0. Now see these equations and what is the physical interpretation of these equations. Equation 12, this equation. Equation 12 represents the equation of motion of a free particle of mass m1 plus m2. This is just a equation of motion of a free particle of mass m1 plus m2 and energy et minus e. Free particle equation of m1 plus m2 and energy et minus e. Thus the translational motion of the center of mass is the same as that of a free particle of mass m1 plus m2 and energy et minus e. Translational motion of the center of mass is the same as that a free particle of mass m1 plus m2 and energy et minus e. This result corresponds to the classical result that the center of mass moves in a straight line with constant speed. This result corresponds to the classical result that the center of mass moves in a straight line with constant speed. Equation 13 is identical with Schrodinger equation for a single particle of mass mu and total energy E, exclusive of the translational energy, moving under the influence of a potential function Vr equal to minus V minus E square upon R. since for hydrogen atom Z equal to 1. The energy E of the relative motion is determined as the eigenvalue of this equivalent problem. So by using these terms, we separate the equation, and there are two kinds of equation. What is the physical significance of this equation? These equations we understand here. In next lecture, we separate the variable, because we know that psi equal to r theta phi, and after that we solve these equations for r theta phi separately. Okay, thanks to all of